Hi, everybody. Thank you so much for joining us today for another Azure Data Academy session. Our series here is focusing on Azure Database for MySQL Flexible Server. I'm Brian Hitney, your Cloud Solution Architect, host, and joined by our SQL engineering team with Avnish and Jim. They will introduce themselves in just a moment, but all of our content is on our Azure Data Academy page, which is aka.ms/ADA. And of course, feedback, we could take that directly in our repo at that previous link, or if you prefer, we have a Microsoft Office form, aka.ms/ADA-feedback. Today's session, infrastructure as code, deployment, Terraform, PowerShell. We're going to cover all of this and how to use it, when to use it. And so I'm looking forward to today's conversation because historically, databases have been one of the most challenging things to transform into infrastructure as code. But before we dive right into that, one quick thing we would like to talk about is coming up in July is a session we'll be doing with the company that we have here today, Avnish and Jim and myself. We'll be hosting a live roadmap and Q&A session. So we're going to take a look at the upcoming release schedule for MySQL Flexible Server. We'll also take any questions that you may have, and we'll hopefully provide some answers at the same time, we hope. And in addition, we'll do a quick recap of the sessions that we've already done. And we're happy to dive into anything further. If you say, hey, back in that high availability session, you mentioned X, could you give us some more information? So we're happy to do that. You can register at aka.ms/MySQL roadmap. That will take you to our event page where you can register for that. And I want just one quick comment is this session is intended for Microsoft partners that are under NDA agreements. So when registering, please be sure to use your company email address because we'll need to do that to verify that you can attend. We will not be recording the session, so we look forward to having you there, and please be sure to bookmark that time slot. All right, so moving on then to our main topic for today is infrastructure as code. And before I turn it over to Avnish and Jim, give you guys the opportunity to introduce yourselves and talk a little bit about today's session.
Thank you, Brian. So this is Avnish. I have been with MySQL product team for past 1 year. I joined Microsoft in September 2017. Spent a couple of years in SQL Server engineering team and now MySQL. Prior to that, I was with Oracle for 4 years, and rest of my career has been in healthcare on the provider side. So really looking forward to this session. But before I start, Jim, I will let you introduce yourself as well.
Hey, thank you, Avnish. Yes, my name is Jim Toland, and I too am on the MySQL Growth PM team with Avnish, and I've been with the company for quite a bit longer. I joined back in 2000, and I've been with the CRM team, and I've been with this team now. I was with Microsoft Learning for a little while, and then I also have been with this team now for about 5 years. So looking forward to presenting this important information to you guys.
Thank you. So as Brian mentioned that today's session would be focused around infrastructure as code and what are the different options we have in Azure or even in third-party solutions. So before we do that, what is infrastructure as code and why it's so important for the customers, especially in the enterprise space? So infrastructure as code is one of the way to manage cloud resources as a software. And it allows you to deploy the same environment in a consistent manner. So for example, if you have an application where you have multiple environments, let's say development, staging, test, and production, and you want to have the same experience every time you provision resources for that application. So doing this infrastructure as code would allow you to support that. And this also important if customers are pursuing DevOps practices, because you can deploy the resources as part of your code deployment. And if tomorrow you are trying to make any changes in the infrastructure, you can continue to do this as part of your DevOps pipeline for continuous delivery. Now, Azure provides multiple options which you can leverage to do infrastructure as code. So we have Azure Resource Manager or templates. We have PowerShell, Azure CLI, and recently we also introduced Azure Bicep. And in addition to these other Azure native solutions, We also have the options to provision Azure resources using third-party solutions like Terraform, Ansible, Chef, Plumi, etc. And each of these solutions support a different file format. So these formats could be YAML, JSON, XML, or HCL, which is for HashiCorp, the provider of the Terraform solution. So just briefly, we won't spend too much time in deep dive into each of these options we have in available in Azure. The focus would be on the Terraform. So as I mentioned that in Azure, we have multiple options. So Azure PowerShell is one of the options, which is an extension of Windows PowerShell, which has been available in Microsoft for a long time. Azure PowerShell provides set of commandlets, which you can use to perform both cloud plane and data plane operations using the REST API calls provided by Azure. And at the high level, whenever you provision a new resource in Azure, it goes to the control plane. And once resource is provisioned and you're trying to leverage the benefits or the features of that particular service, then it goes through the data plane. And then you have the Azure CLI. So Azure CLI, like Azure PowerShell, is support multiple operating systems. So it supports both Windows, Mac OS, as well as Linux. The one distinction between PowerShell and CLI is that PowerShell, you can basically write your code in PowerShell scripting, versus in Azure CLI, you have to leverage different shell from the given operating system. So if you're planning to use Windows operating system, then you will be using shell. Versus if you are using Mac OS or Linux, then you will use bash scripting. And then it comes to ARM or Azure Resource Manager, which is native to the Azure. So every time we release a new service or new feature within Azure, then you would have the API calls immediately available, whether it's a private preview, public preview, or GA. And support for PowerShell or CLI may or may not be available at the time of service release or feature release. It will definitely be available, but sometimes it's not available as soon as we release the new feature or new service. And like any of these options, you can provision pretty much every single resource we have available in Azure. And you can use different tools to write the code. For ARM templates, we have support for Visual Studio Code, or even Azure Portal. The code for ARM templates is available through JSON. Now, recently, we also introduced Bicep. And Bicep, you can think in a way, is a revision to ARM templates or ARM, Azure Resource Manager, because it provides the same core functionality and same runtime experience. And behind the scene, when you compile Bicep code or files, it compiles into the JSON files, and then it sent to Azure for deployment. So it just provides you much better experience, because Bicep code is very small compared to JSON file, and it's easy to understand. But behind the scene, it gives you the same experience. So as we work with the customers, one of the questions we hear from the customer that what does it make sense to, or which solution would make sense to leverage for infrastructure as code? My response has been really it depends on organization cloud strategy. So if you are an organization who is pursuing multi-cloud strategy or planning to pursue multi-cloud strategy, then it makes sense to start with cloud agnostic tool, whether it's Terraform or something else. But if you are committed to Azure cloud provider, then it would make sense to leverage Azure native solutions. And then it comes to which one would make sense to choose between these options we have available in Azure, whether CLI, PowerShell, or ARM templates, or Bicep. Now it depends on the organization comfort level or skill sets. Some organizations are very comfortable with CLI or PowerShell. Then they may prefer to use one of those options or ARM templates. The only distinction I would highlight again, as I mentioned in the beginning, that you would have support for ARM templates as soon as we release a new service or new feature. And support for PowerShell or CLI may or may not be available immediately. It will definitely come sooner, but sometime we have seen a delay of month or couple of months. And similarly, for support for Terraform or other third-party solutions, it will come maybe 6 months later, or really depends on the demand. And as I mentioned, that Terraform is it's an open source, and it really supports hundreds of cloud providers: AWS, GCP, Alibaba, VMware, Kubernetes, you name it, and Terraform support would be there in majority of the cases. Both ARM templates as well as Terraform provide different methods for variables declarations, conditions, and how to really write the code. Very powerful. And one thing I would also highlight is that let's say you are initially committed to Azure and you're using templates. And later on, your organization decided to pursue multi-cloud strategy. Then switching from ARM templates to Terraform requires a decent amount of effort. Obviously, it depends on how much effort you have, how many ARM templates you have to convert, and the complexity of those efforts or these templates. But definitely, it requires significant effort because the language is different, and how the variables or parameters are managed between these two solutions is also different. So something to keep in mind. So rest of the presentation would be focused around Terraform. We have multiple slides to cover Terraform, and towards the end, we will walk through different Terraform forms we put together for this presentation to provision multiple resources. So as I mentioned, Terraform is an open source infrastructure as code software provided by HashiCorp organization. It supports multiple cloud providers. And at the high level, it has two components. One is Terraform Core, which really provide the basic infrastructure. And then it relies on different providers to provide set of APIs, which you as a customer can use to provision resources within these cloud providers. It has a standard interface for creating resources by providing input and returning outputs as you provision different resources. And depending on the complexity of your infrastructure as code or resources you are trying to provision, it provides an option to modularize your entire solution. And you can call these modules in a Terraform calls in Terraform to simplify the coding of these solutions. And at the high level, it has 4 phases. First phase is to basically, obviously, you have to write the code to provision different resources. And then you initialize the working directory in which you have all the Terraform configuration files to provision or manage cloud resources. Then you do the plan, and you can think Terraform plan as a dry run to validate your configuration files and identify which resource is a new resource, which resource is an update, versus which resource you are trying to delete or destroy. So it goes through the Terraform plan, and then you finally apply the plan. And during the apply, it basically goes through all these configuration files to execute your provisioning. So as I mentioned, that Terraform has 2 important components. One is the Terraform core, and then you have the Terraform plugins, which are provided by different cloud providers. So Azure, AWS, each of these cloud providers have set of plugins which Terraform expose to manage resources in these cloud providers. And you can see the availability of these different cloud providers using this Terraform registry. So for example, you have this, here is the Terraform registry. And as you can see, we have AWS, Google Cloud providers, Azure, Kubernetes, Alibaba Cloud, Oracle, literally hundreds of cloud providers, so hundreds of providers collaborating with Terraform to export their solutions. And for each provider, you have to specify the provider requirements and the configuration for the provider. So for example, here we have Azure as an example. So in this case, HashiCorp/Azure Resource Manager. Then you specify the version you want to use and the Terraform CLI version. So that's the basic information you would be providing from the requirements perspective. And then you can specify provider specific information. So for example, in this case, I'm using this subscription ID. You can also specify location and some other information. Alternatively, you can also have all this information as local variables or input parameters. And once you do the Terraform init, then it will create the dependency log file automatically. And I will show you some of the files created by these different Terraform input or plan as you run the code. So like every other language, Terraform also has the concept of input, output variables, as well as locals block. And each input variable is declared using variable block. So here is the example of one of the variable. So here we are defining this resource group variable, description of the variable, type of the variable. So in this case, we have a string and the default value. You can also specify where the variable can have null or not, and sensitivity, that how sensitive this variable is, whether it's an input variable or output variable. And based on the sensitivity, so whether you if you specify true, then it will basically encrypt the variable information. And then you can define the condition of the variable. So for example, in this case, I'm saying that variable length must be greater than 4. And first 8 characters of this variable should have that string. If this condition is not matched, then it will display this error message. So it really allows you to validate your input parameters for different variables. And once you have these variables defined, then you can reference those variables in your code using var as an object. There are two options to provide input for these variables. One, you can do it at the time of Terraform apply. So in this case, you have this variable name equal to variable value, comma, other variables. Alternatively, you can also define these as environment variables. So tf_var, and then the variable name and the value you're trying to set. So there are two options to set the variables. One is to provide this input as part of the Terraform apply, or define this as a environment variable. And then you have the output block. And I have examples which I will share during the demo. And finally, locals block. To simplify the infrastructure as a code, you can have the Terraform support the concept of modules. So for example, we have this module server in which you are provisioning VM, IP, firewall rules, storage, etc. So you can really modularize your infrastructure as a code to simplify this. And we have different configuration files. Each file ends with .tf extension. The standard for the variables, I'm using variables.tf, and then I have for the outputs. And other files to be aware are like terraform.tf state. These files are created as you run terraform.init or terraform plan. So these files will be created, and it's okay to run those files or run these multiple times. So you can have terraform init multiple times. You can run terraform plan multiple times. It won't cause any problems. So in terms of the workflow, as I mentioned that obviously you will start to authoring your infrastructure as code. Once you have these Terraform configuration files, then you run Terraform init in the working directory you're trying to run the code. And then you can do the plan to validate the configuration files and also identify this is all part of the plan that which resources would be new resource, and new resources would be indicated with plus sign. And if you're trying to delete a resource, those will be marked as minus red sign. So all that information would be available when you do the Terraform plan. And you can either have Terraform plan output generated on the screen, or you can also save it as part of the plan file. And once you have the Terraform plan, then you can apply it to basically provision different resources. So some of the common commands you would see that init, validate, plan, apply, and destroy. And other commands you might see is FMT formatting, graph. Graph is basically to visually show you the relationship between different resources you are provisioning. And one thing I forgot to mention about Terraform, that Terraform is very good in identifying the dependency between different resources automatically. You don't have to specify the dependency as you are trying to provision resources. So for example, if you're provisioning a VM in a virtual network, you don't have to specify that virtual network must be provisioned before you provision the VM. Terraform is smart enough to provision the virtual network first before provisioning the before provisioning the compute resources. Because our session is all about Azure DB for MySQL. These are some of the Terraform calls which you can use to provision Azure DB for MySQL resources. So in our previous sessions, we talked about the deployment options for Azure DB for MySQL. So we have single server, and these are some of the resources we are exposing. So you have Azure RM underscore MySQL underscore server to provision single server instance. Then you have this MySQL underscore database to create the database, to manage the custom managed keys, and so forth. Similarly, these are some of the resources which are available for flexible server, which is another deployment option. So Azure RM underscore MySQL underscore flexible underscore server to provision flexible server. Then similarly to create the database, which is same as single server, and to manage the firewall rules. So these are some of the configuration files I put together for this demo. So I will walk through each file slowly. And if you have any questions, let me know. So I will start with the provider, which is one of the main configuration file you will start for any cloud provider. So as I mentioned in the presentation, you have this resource provider block where you specify the provider. So in this case, we have this Azure Resource Manager. If you're using AWS, then it would be something related to AWS. Then you specify the version. So in this case, we are saying that we want to use 2.65. So 65 represents patch version. And then 2 represent major minor version. And then you specify Terraform CLI version. And here you specify what are some of the information or the configuration you want to use for Azure. So subscription ID is this much here. It could be something else. Then I have this file variables to define the different variables. So resource group underscore V is one of the variable to provision the resource group. Here is the default value. I'm saying it cannot be null. Sensitivity is false. And then condition and error message. Similarly, this is for region. So my default value is East US, and it cannot be null. So you can define all these different variables. And here is an example for locals block. So common tags is one of the local block. When you use this in your configuration file, it will basically create 3 tags for a given resource you are provisioning. So what I'm saying, owner is Azure MySQL engineering. So that's one of the tag it will create for that resource. It will also create a name tag with this value, and finally environment. Another configuration file here I have is the output. So for each resource, you can identify what the output you want to generate. So for example, for a resource group, it will provide the resource group ID. For the location, it will provide this location output. And similarly for text and other output variables. So once you have these basic configuration files, then you can provision different resources. So for example, if you are trying to provision network resources, this particular block will provision a TerraNet Terra-VNet virtual network. Here is the address space range and resource group. I'm basically using the variable I provisioned or I defined in the beginning, and same is true for the location. Now here I'm saying that it depends on the resource group. So as I mentioned that you don't have to specify the dependency, but just for the example, I'm using this here as well. So I'm saying that it will depend on the resource group. So resource group must provision first before you provision the virtual network. Then once your network is provisioned, then you can provision subnet. So resource group name, network name, prefixes for the address space for the subnet, and service endpoint. And this is for the delegation. So few Azure service, including Azure DB for MySQL flexible server, requires dedicated subnet. So in this case, you can use this block to say that, okay, this subnet is dedicated for the flexible server. And this particular piece of code is to provision the private DNS, which is the requirement for flexible server. If you are provisioning that resource in your private, in your VNet, and then you specify the network links. Another example I have, or the configuration file I have, is for the storage provisioning. So you specify the different variables, the network rules tag, and then this is for the log analytics workspace. So if you're trying to do the log analytics for a particular resource, this is the code you can use to provision the log analytics workspace. And then I have a couple of examples to provision single server and flexible server. So this is to provision the single server. Again, this is the name of the resource it will provision for the single server. Then location I'm basically getting from the input variable. Same is true for the resource group. And I'm hard coding the login name and password. You can certainly have these as input parameters as well. And you can define the those parameters as sensitive parameters so that the value you provide is masked during the display. Then you can specify the SKU name, the storage you're allocating, the backup retention days, and whether it's geo-redundant or not, and auto-grow storage. By default, it's true. You can identify whether encryption is enabled or not, SSL enforcement, and you can also specify these timeouts. So for example, for any region, if resource provisioning is taking more than 60 minutes, then it will automatically time out, rather keep on trying. And you can also define the delete timeout. So there are different timeouts you can specify. Then in this case, I'm using this tag. So it will basically create this tag for this resource. And these are the firewall rules. And once this one is provisioned successfully, then it will create this database name database within this single server instance. Similarly, for flexible server, similarly, you specify all the variables. So SKU name, zone. So flexible server, you can specify the zone where you want to provision your flexible server instance. And since it is provisioned in the VNet, you specify the dedicated subnet, private DNS, which we provision within the network configuration file. Storage, you can specify the maintenance window. So day of the week, start hour, start minute. And then you can also specify, so in this case, I'm using this high availability option as a variable. So during the apply, you can specify whether you want to provision flexible server with HA configuration or non-HA. And based on the input parameter or input value, it will take appropriate actions. Again, you can specify the timeout settings. These are for the firewall rules, database creation. Again, dependency is not required, but for the example, I'm using this. And you can also provision the read replica using the Terraform. So in this case, I'm saying that it depends on this flexible server instance, which is the primary instance. And then you specify the name of the read replica, the resource group name, location, and the create mode you have to specify as replica to indicate that this particular resource should be provisioned at the read replica based on this primary instance, based on this resource group ID of the source or the source server ID. So I think I walked through all the, so I mentioned that when you run the Terraform Terraform plan, it will generate this Terraform state. And this is the log file I mentioned. So when you run the Terraform init first time, it will create this log file. The way to run this code is that I have this command line prompt, and I'm in this directory where I have all the Terraform configuration file. So first step would be to run the Terraform init. And in this case, because I already ran this before, it says the Terraform initialized in an empty directory, and directory has no Terraform configuration file. You may begin working with Terraform immediately. Then second step would be to do the Terraform plan. My apologies, I'm in the wrong directory. Let me switch to the right. So let's run this again. So Terraform init. So it's going through the initialization, and initialization completed successfully. Let's do the Terraform plan. So it takes some time to do the Terraform plan run, but soon it will start generating the output.
So while this is happening behind the scenes, maybe this would be a good time to ask, those coming from PowerShell, are likely used to desired state configuration or DSC just to help streamline. Is that what that state file is the equivalent of in Terraform?
Yes. So what Terraform does is that it validates the configuration files you have in that working directory. and then it identify which resource is a new resource versus which one requires update and which one will be destroyed. So if you look at this plan, so you can see these different signs. So plus sign, plus sign. So in this case, all these which have the plus sign means all these resources will be provisioned, whether it's a reprovisioning of the same resource or your provisioning is first time. But let's say if you have provisioned a VM with 4v core using the Terraform configuration files, and later on you change the configuration of that VM from 4v core to 8v core, then this plan will indicate that you're scaling up this VM from 4v core to 8v core. Or for any region, if you decide to delete that VM, then it will show as a minus and the resource name to indicate that resource will be deleted as part of this configuration. So unfortunately, I don't have anything on the delete side because I'm just provisioning these resources. But you can think Terraform plan as a dry run to make sure that everything has been configured or provisioned, everything has been planned successfully before you do the apply. And final step would be to do the apply, and then it will start provisioning different resources. So it will take some time if I run this to provision all the resources, but that's the way Terraform works.
That's great. And so it seems like then the plan can be very useful at even just detecting differences between environments. If you're trying to troubleshoot an issue and you don't know exactly where something may have gone wrong at some point, and you just know you need to compare, you can run that against that environment just to see how it analyzes and what the differences are.
Absolutely. I think this is one of the a nice feature Terraform really provide, not only to validate the configuration files, but also to make sure that it gives you a complete visibility to indicate that which resources it's going to provision versus which it's going to destroy or update. So that's all I had for this session, Brian. We can go through any questions you or Jim might have.
I'm curious at how. Yeah, no, this is great. This is really useful. I have not used Terraform, so I appreciated getting this insight. How about guidance for those who, they either might be new to this completely, or they might be coming from, say, just using PowerShell or another tool, trying to decide between, do I use Bicep, for example? Is that considered the new tool? Do I decide to migrate to Terraform? And one of the takeaways that I've gotten out of seeing your demo and the points you've made during the presentation is it seems like the biggest concerns are really around support for multiple cloud environments and then feature latency, right, for things to be integrated. Would you say that those are the two biggest ones? Are there any other considerations?
No, I think these are the two bigger ones. So as I mentioned in the beginning, that if your organization is pursuing or planning to pursue multi-cloud strategy, then it makes sense to leverage cloud agnostic tool. That being said, we should keep in mind that the API for a service in Azure may take some time before it's available in a Terraform. It could be 3 months, 6 months, really depends on the demands from the market. Now, if you're committed to Azure, then we really have three options now: PowerShell, CLI, and Bicep. But as I mentioned, Bicep is the revision to ARM templates. So I would suggest to start with Bicep. There is no point to start with the ARM templates now. If you're starting new, just go with Bicep. But between Bicep, PowerShell, and CLI, I would say it really depends on the comfort level or your skill sets. If you're comfortable with PowerShell or CLI, then you may decide to stick with those options because you have been using these tools for a while. Only thing to keep in mind is that there is a slight latency in having these CLI or PowerShell availability for different features or services we have in Azure. It could be a month, couple of months, but not a lot.
Great, thank you. I don't have any other questions. I'm not sure if Jim does. I think that might wrap us up.
Yeah, I basically was going to ask some of the same questions you did. I thought there was a great information presented, but just kind of looking for like the best practices type things. And I think that y'all covered that nicely. So great information.
Great. Thank you, Avnish. And thank you, Jim. Why don't we talk for a moment about the upcoming session in July on the roadmap? Oh, there we go. Thank you. We're going to have YouTube back on July 14th, 1 o'clock Eastern time. We're going to be doing the live roadmap and Q&A session. I'm looking forward to that, and I hope all of our partners are as well, because one of the most frequent questions that I get as a CSA working with partners is understanding the roadmap and when features are coming, and to have a line directly into U2 to discuss that, I think is fantastic. So we're looking forward to having that coming up in July. We'll also take any questions that you might have, because we are going to be live. So if you have any other questions on topics that we have previously covered, feel free to bring those. And obviously, any questions that come up during the presentation on the roadmap, feel free to bring that as well. I do recommend that you register early using your company's email address, because the session is open to Microsoft partners who are under NDA. We'll be discussing the roadmap, and we won't be recording the session, so you will not be able to go back, unfortunately, and view it afterwards like you typically can with many of our presentations. So we will have to see you there live in order to give you the presentation. But hope you're able to join us, and we look forward to having you register. You can check it out at aka.ms/MySQL roadmap. And in the meantime, Avnish and Jim, thank you so much for taking the time to go over all of this information, and I really look forward to talking with you in the roadmap session.
Thank you, Brian.
Yes, thank you very much, Brian, for pulling this together.
Sure. Take care, everybody.